Hello and welcome back. This is Pratik here. This is the second part of our ongoing tutorial series on how to run an application inside Docker and then push it to an AWS server. In this section of our video, we're going to talk about how we can push our code to AWS and access it from that server. So we already saw what Docker is, how to build a Docker image, how to run a container from that image. So now we are gonna push that image to a repository. So it's gonna be fun. Let's get started. I have talked a lot about Docker Hub. So what is Docker Hub? It's basically GitHub for Docker images. That's what I call it. But all jokes apart, Docker Hub is basically a centralized hub for pushing your images, the images that you build. So it's basically free. You can create an account by signing up. I already have an account, I can sign in. But the problem with Docker Hub is it's free. Well, it's not a problem. It's great that it's free. But suppose you have an application that you don't want to share with everyone. So as it is free, it's also public. So anyone can download your image. But you don't want them to download it because you think this is going to be the next big thing in the tech industry and you want to sell it. You don't want anyone to steal your idea. So you would need to buy a premium account, or you can use AWS. But I'm not going to use Docker Hub today. So I'm going to use AWS. So this is the AWS Console. As you can see, here are all the services that AWS provides. There are a lot of services, but today I'm just gonna look into Elastic Container Service. So if we head there, you can see here are 3 sections: clusters, task definitions, and repositories. For now, we're gonna use these repositories here. So I want to push the image I built here. So let's create a repository first. We are gonna name it node Twitter stream. As you can see here, it already provided me with an URL. So when I create, I can push the images to this repository using this URL. So let's complete it. Yeah, it's created successfully. Here are some of the commands that I'm going to use in a short while. So let's click done for now. Yeah, so you can see it's empty now. So the next step is, okay, so we had our image here. So if we see Docker images, here you can see this is our node Twitter stream image. So basically we want to push this image to ECS. So if we click this view push commands, here are the set of commands I'm going to use. So first of all, I'm going to use this command. So what this does is it basically logs into ECR. So, but for using that, I have to install AWS CLI using pip. So pip install AWS CLI. So it can install a CLI tool provided by AWS for using commands, using terminal to interact with AWS. So it's gonna download the AWS CLI package. And it's inside my virtual environment, so nothing's gonna get messed up when I get out of this virtual environment. Let's wait for it to get done. Yeah, it's done. So now I'm going to paste this command here and hit enter. So it basically generates an authentication token for logging into ECR. So I'm gonna paste it again. Yeah, login succeeded. So now I can follow here. So it says that docker build -t. So we already did that. We tagged it. Now we have to tag it according to the URL of the image. So we are gonna run this now. So now if we run docker images, as you can see, we have this extra image here that was tagged from our node Twitter stream image. So Now we are gonna hit this command to push our image to this repository here, the latest version of our image to this repository here. So now the push would get started. So basically it's gonna upload the image, so it's gonna take a little while, so let's wait. So as you can see, the pushing is done, so we can check it here. So if I just refresh the page, yeah, so we got an image here and it's tagged latest, so we can just pull it from here now. So now it's time to create our cluster. We have created a repository here, we have pushed our image to the repository, so now we can create a cluster so that we can move forward with the rest of our project. So now for creating cluster, let's hit create cluster. We're gonna choose EC2 Linux, then give the name node Twitter stream. We're gonna choose on-demand instance here. So if you choose on-demand instance, you have to pay by the hour, so it's gonna be a bit cheaper. Then we'll choose the EC2 instance type as T2 small. The higher you choose the instance type, the more you have to pay. For T2 small, it's enough for our application because our application isn't that resource hungry. So basically instance type would define how much resource you are going to get for your application, for your instance. So the number of instances is going to be 1 because we don't need too many instances for our application, as the load to our application wouldn't be too much. But if you had a production application where you would expect a bit of load, so you can select higher, you can choose 2, 3 here and balance your load. And then we're going to choose the EBS storage as 22. That's the lowest value. You cannot choose any lower value. Basically EBS storage would be the storage in gigabytes that would be attached to your instance. Sorry, we would choose 1 here, not 2. And then you're gonna select a key pair. So basically a key pair is necessary if you want to access your instance using SSH for maintenance or stuff. So if you don't have your so basically you wouldn't have any preset here. I set it up here, set it up the SSH key pair from here. So if you go here, you can create a new pair by assigning a name, or you can import from your machine if you have it in your machine. So then we are gonna move to the networking part. So here VPC is basically a huge concept to cover. We can probably take another session on it, discussing the whole thing about VPC, but now for now I'm gonna describe it briefly. So a VPC is basically a logically separated, logically isolated section of the AWS cloud where you can launch your AWS resources. Why would that be helpful? So basically you can divide it in 2 parts. One would be private and another would be public. You can create subnets in it. So if you create a public subnet, then people outside of your VPC or things outside of your VPC can access your resources. And if you assign a private subnet to your resource, things outside our VPC cannot access it. So our web server is gonna be inside a public subnet because we want to access it from the internet. But if you had a database or stuff, you don't need people to access it from outside. So you're going to put it inside a private subnet. So we already have a VPC created here. So I'm going to choose my existing VPC and choose a already created public subnet. Maybe we can discuss about it in a later session. Okay. Now it's time for security groups. So also you can create security groups, but I have already created a security group. So let's see what are the security groups. What is a security group? So basically a security group assigns some rules to your instance. What are the rules? So one is inbound rules, another is outbound rules. So what are these? So inbound rule is basically what traffic comes inside your instance, and outbound rule would be what traffic goes outside from your instance. So we want all traffic to go from our instance to outside. There is no restriction there, but we want to restrict what comes inside our instance. So we just open these two ports here. The 22 port would be for SSH, so you can SSH using the key pair you imported earlier, and you would I am opening the 3000 port here because our application uses 3000. For your production, maybe you can create an ELB and then access that ELB, because accessing the instance directly is not a great idea. But we are not going to cover ELB here. Maybe later in some other session. Okay, so I'm going to attach this security group to our instance. We are not gonna choose any, we're gonna go with the default one here. For instance, IAM role, we don't really need it for this application. So then we hit create, we wait a bit, it's gonna start creating the cluster. So as you can see, it has started creating the cluster. It's gonna take a little bit of time to create everything. So it created a ECS cluster and then attached the IAM role default policy. Then it's going to create a CloudFormation stack. So CloudFormation is basically another service AWS provides. So ECS cluster uses that CloudFormation stack internally. We don't need to worry about that. So it's created successfully. Now if we view the cluster, so our cluster is active. But there are no tasks running because we haven't set any task definitions yet. If we go to the ECS instances tab, we can see this is our instance that is active. So if we go into the EC2 instance, we can see the details of that instance. So EC2 is another service that AWS provides. It stands for Elastic Compute Cloud. So it allows you to launch virtual instances, so basically virtual machines inside AWS servers. So as you can see, there are public IP address and there is public DNS. So basically you got public DNS and public IPv4 address because we launched the cluster inside a public subnet. That's why you got these IPs, and you can just use this IP addresses to access your application. So now let's create a task definition here. So what is a task definition? The task definition is basically saying what task the cluster is gonna run. We have to create a new task definition here. We click here, enter task definition, node to stream. We don't need any role, we don't need network mode. Now we add a container. So we need a repository URL for creating that. We're just gonna hit cancel here, go to our repository, go to node to stream and get this URL from here. Then we're at container. Container name would be node to stream. You can name anything here, paste it, and then add the latest tag. So it's going to fetch the latest image from this repository. So a memory limit is basically limiting how much memory the container is going to use from our instance. So we want to limit it to 512 megabytes. Then we're gonna map 3000 port to 3000 port here. So if you remember, we mapped this port in our docker run command. saying -p 3000 colon 3000. So we're doing the same thing here. We don't need CPU units here. So we already have our entry point in the Docker file. We don't need it here. We already specified our working directory. We don't have any environment variables, so we can just hit add. We don't need anything else here. So we can also configure it with JSON. So basically these are the same things that we entered. You can copy the JSON and maybe automate it using any language. Then we hit create. That's gonna create the task definition here. So the task definition has been created successfully. Then we head over to our cluster. So our cluster is running here. We go to tasks and run a new task. Here we select node Twitter stream. The number of tasks is going to be same. It's going to be 1, and run task. So we are going to have to wait until the status goes from pending to running. It's not going to be very long. Still pending. So as you can see, the status came to running state here. So we head over to our instances tab. Here, this is our instance. So if we hit this is going to take us to the EC2 section. Here, as you can see, this is our public DNS. We're going to copy it. We're going to paste it there at the 3000 port because our application communicates using the 3000 port. If we run it, so this is it. As you can see, our application is running. So we have successfully completed our series here. We have built a Docker image and then ran the Docker image inside our local machine, and then pushed that image to ECS repository, created a Docker cluster, and then we ran the task from the ECS cluster. So hope you enjoyed it. If you have any questions or any queries, please comment below, hit the like button and subscribe for more. See you soon.